This is Mrs. O'Neill for AP Chemistry, Chapter 15, Section 7, Part 2. All right, I'm going to say this name again. Le Châtelier's principle. Now let's look at these problems and what they'd be like. All right, so here's an example. Now, this heat is already given to us in this reaction. Just as a forewarning, sometimes they give you the delta H value, so then you got to figure out if it's exo or endo, and that's why we spend so much time with the negative versus positive of that delta H. And the other thing they might just tell you is if it's endo or exo. So regardless, the first thing I would do is take that heat and put it either as a reactant or a product if they're giving you that information. Okay, if we're adding Cl2, if we're adding chlorine, well, if I add Cl2, that means I'm going to shift to the left to get rid of it. So shifts left. Heat, now that heat is a reactant. If I remove it, I'm removing the heat. That means I'm going to want to shift to replace it. It's also going to shift to the left. Removal of the PCl3. Okay, so here's our PCl3 over here, phosphorus trichloride, right? So if I'm removing something, I'm going to want to replace it. So if I take it away, it's going to shift to the right to replace it. Increase in pressure. Okay, if they're asking about pressure, my first thought is I have 1 mole over here and I have 2 moles over here. So I'm going to put my P where there's more moles. Okay, well, if an increase in pressure, that means I'm going to put more pressure here on the right side and I'm going to shift it now to the left. And again, if you want to pause it, there's more information there as to why the answer is that answer. Okay, so can you do number 2? Now, unfortunately, they don't give you a delta H value. They don't tell you if it's endo or exo. But if I look at A, B, C, D, they're not even asking about heating it up or cooling it down anyways. So we're good there. However, they do ask about pressure. So you might want to put that P on either the left side or the right side. So pause the video and see if you can come with shift left, shift right, or the other possibility is that there's no shift at all. Okay? Should have gotten that, and that, and that. How about D? Decrease in pressure. Well, I see 4 and I see 1. So I have 5 moles total on the left as reactants. 1 plus 2, I see 4 moles total on the right. So I would have put the P on the reactant side and got the answer of shifts left. All right, so can you take this next couple of questions as a quiz? Pause, see if you come up with an answer. Hopefully that makes sense. Pause, see if you can come up with an answer. Hopefully that makes sense. Pause, can you come up with an answer? There you go. 4, interesting. Can you come up with this answer? Hopefully that makes sense. If it doesn't, I expect some questions. Okay, how about this? Again, this is another one of those shift left, shift right. Ooh, I do see heat, so they might actually ask us something about temperature. And the other thing, just real quick to point out, I have 2 moles on this side, 2 moles on this side. So if they ask about pressure, what will happen? So pause, see if you can come up with the answers. Did you get that? Did you get that, right? There's no shift at all. I just kind of told you there was 2 versus 2, so there's no shift in pressure, and therefore there would be no shift in increasing or decreasing volume as well. How about that? And that. Remember, these are all gas phases, right? These all need to be gas phases if we're dealing with equilibrium, so that's why it says water vapor, and it didn't just say water, right? Water vapor meaning that it is in the gas phase. So this one might be a little bit of reading. So again, pause. You might see something like this as well relating to more of that biological situation. And we talked about biochem a lot in these couple of chapters. Hopefully that makes sense. So number 7 is a conceptual question. This is where I really suggest pausing the video, not only kind of jotting this down, but counting how many you have, how many circles you have versus how many like filled in dots you have, whatever you want to call them, circles versus dots, right? So it's going to take that information in order to answer this question. And these are questions that we do see now on the AP exam because it's more visual. It's trying to get you to understand these concepts on the molecular level, okay? So pause, read, Did you get B as an answer? I hope so, but if you didn't, here's the explanation as to why. So again, if you didn't get it, pause and make sure you're understanding that ratio. So let's look at that ratio again, that box. This is a new question. See if you can come up with an answer. Hopefully that makes sense. Now, can you explain your answer just like I will do in the next slide? Hopefully you say something like this. So not only might this be a multiple choice question, but it also might be a free response question where you have to do a little bit of explaining the ratio and how it varies. How about letter C? Can we answer this? Does that make sense? If it does, try to put some explanations together. Otherwise, hopefully this will help you put some kind of story to your answer. Okay, how about give it some thought? And hopefully, again, pause. And this is now talking about those IMFs. This could be a good response question. One more. No, okay? Catalyst, only thing that the catalyst does is speed up the reaction, okay? So if we look at this, we have a catalyzed versus a non-catalyzed. So how much faster does a catalyzed reaction compare? We're going to say maybe between 2 and 3 times faster. But now if we look at this box, we have our K, our constant, right? We didn't say anything about a catalyst affecting our K. Well, why doesn't it affect our K? Well, because our concentration of B and our concentration of A is going to be the same in our equilibrium. The catalyst just lowers that activation energy, taking that different route or that different reaction pathway, right? So it lowers how much energy is needed to get to products, but our reactants and products value are the same. Okay, we'll see you in class.